Good morning. Now we start the next part of the methods for determining reaction mechanism. In last lecture, we have studied the what is meant by organic reaction mechanism and its definitions. In chemical reaction, mechanism represents the actual process by which the reaction has taken place. And we see the example of aldol condensation between acetone and benzaldehyde. It indicates which bonds Ashish to the it indicates which bonds are broken in hot involved and the relative rate of each. The positions of all atoms, including those of solvent, molecules, energy of the system at every point in the process needed to be specified in a mechanism. That means the position of atoms matter with the solvent, interaction of the reactants with the solvents, and energy of the system, whether the reaction is exothermic or endothermic, how it is proceeds. At every point in the process need to be specified in a mechanism. When a new reaction is discovered, we design or discover new reactions, more than one mechanism proposed. Ashish, तुझा आवाज mute कर, it will be disturbed for the students also and as well as teachers. Best mechanism is the one which fits all the evidences sought. म्हणजे generally mechanism आपण जे evidences देऊ त्याच्यामध्ये ते mechanism fit व्हायला पाहिजे. And it is rarely possible to provide complete informations like structural, energetic and stereochemical about the pathway that is transferred by reaction, and it is subject to change with the discovery of new facts. The mechanism also changes with the discovery of new facts. And there are examples of reactions which by different mechanisms under different conditions, and in each case the proposed mechanism completely explains all the data. Now, organic reactions generally involve the cleavage of more than one covalent bonds. Organic reactions मध्ये काय होतं? Cleavage of bonds. On the basis of cleavage of bonds, organic reaction mechanisms are characterized into three types. First is the heterolytic bond cleavage mechanism. Second, homolytic bond cleavage mechanisms. And third, pericyclic reaction mechanism. म्हणजे organic reactions mechanism काय? We characterize by three different ways. One is the heterolytic bond cleavage. Second is homolytic bond cleavage mechanisms and pericyclic reaction mechanism. Homolytic bonds cleavage means heterolytic bond cleavage if a bond breaks in such a way that both electrons remain with one fragment, and the mechanism is called heterolytic mechanism or heterolytic bond cleavage. What happens in heterolytic bond cleavage? When the bond breaks, suppose CH3 CO CH2 H. This is acetone molecule reacts with base NaOH. Reacts with base NaOH. The bond pair electron present between this CH2 and H hydrogen methyl, this bond pair, this is the bond pair, and this bond pair when shifted to completely towards CH2 म्हणजे OH minus असे काय, it abstract this proton. It abstract this proton. When it abstracts this proton, at that time the bond pair electron present between this carbon atom and hydrogen is shifted towards completely carbons. It shifted towards completely carbons and they forms the carbanion, and such types of cleavage is called the heterolytic bond cleavage. आणि अशा टाईपच्या क्लिवेजला काय म्हणायचं? हेटेरोलिटिक बॉन्ड क्लिवेज. CH3 C double bond O CH2 minus. This is called the heterolytic bond cleavage. Here we generate carbanion as a intermediate. जिथं कुठला charge generate झालेला आहे? Carbanion we forms. That means in organic chemistry, when bond pair electron is shifted towards one atom, that is called the heterolytic bond cleavage, and they generate the cations and anions. Second example, if we carry the reaction of ethyl alcohol or in isopropyl alcohol CH3 CH OH and CH3. If reaction carried with concentrated H2SO4, HSO4, HSO4, whatever the lone pair electron present on alcoholic OH, this lone pair is donated towards the proton of sulfuric acid H. And what the intermediate forms? The intermediate form is like this: CH3 CH OH2 plus again CH3. The positive charge is present on the more electronegative atom. Oxygen varti काय हा positive charge, and this is not the feature in chemistry. That's why when the bond break between carbon and oxygen, हा bond does break होईल, the bond pair electron present between carbon and oxygen is shifted towards the oxygen atom. Why? Oxygen is more electronegative and it has strong tendency to attract the bonding electron towards itself. And whatever the charge generated on carbon atom is CH3 CH plus आणि CH3. Now we generate the intermediate is the carbocation, and this fission is called the heterolytic bond fission. आणि अशा फिशनला काय म्हणायचं आपण? Heterolytic bond cleavage or heterolytic bond fission. That means the bonding electron pair is shifted towards one atom, which is more electronegative, and the respective atoms carry the negative charge, which bonding electron pair is shifted towards, and the other atoms carry positive charge. इथं आता कार्बन वरती कुठला चार्ज आलेला आहे? Positive charge. That is, we generate here carbocation intermediates. इथं कुठला intermediate तयार झाला? Carbocation. That this is the first types of mechanism is heterolytic bond cleavage. म्हणजे पहिलं mechanism चा type काय? Heterolytic bond cleavage. And in heterolytic bond cleavage, if a bond breaks in such a way that both electron remains with one fragment. आता we see the two examples, one with acetone, the alpha proton is abstracted by base sodium hydroxide. The bonding electron present between carbon and hydrogen is shifted towards the carbon atoms with one fragment. एकाच fragment मध्ये राहिली bond pair. And second example is 2-propanol reacts with sulfuric acid. They generate carbocations. Carbon carry the positive charge. Bonding electron shifted towards the water. यावेळेस कुठे शिफ्ट झाला ऑक्सिजन कडे, and that's why it carries the positive charge. It necessarily involve ionic intermediates, although they often do. Now next, homolytic bond cleavage. If bond breaks in such a way that each fragment gets one electron, that is free radicals are formed, and such reactions are said to take place by homolytic or free radical mechanisms. हेटेरोलिटिक लक्षात आलं म्हणजे दोन्ही बॉन्डिंग इलेक्ट्रॉन एका फ्रॅगमेंट मध्ये जातात आणि पॉझिटिव्ह अँड निगेटिव्ह चार्ज ते तयार होतात. Now, homolytic bond cleavage mechanism, if a bond breaks in such a way that each fragment gets one electron, free radicals are formed, and such reactions are said to take place by homolytic or heterolytic free radical mechanism, homolytic or free radical mechanisms. We see what is the homolytic mechanism. Suppose we take CH3H and this compound exposed to the sunlight or photochemical reactions. Suppose it exposed to the photochemical reaction or light radiation. Photochemical reaction, chemical reaction. The bond between carbon and hydrogen is break symmetrically. It should be break symmetrically like this. The bonding electron present, म्हणजे एका बॉन्ड मध्ये दोन इलेक्ट्रॉन असतात. The bonding electron present, one bond contains two electron. One electron is shifted towards methyl group CH3 and second electron is shifted to the hydrogen atoms and they form CH3 dot plus H dot. H dot. Such types of reaction is called breaking is called the homolytic fission or homolytic cleavage. म्हणजे it should be break symmetrically and the bonding electron pair is distributed equally. One bonding electron pair goes to the one fragment, generate first free radical, and second bonding electron goes to the second fragment, that is second free radicals. They generate two free radicals. Again, one example with propenes. CH3, CH, double bond CH2. And if you carry the reaction in presence of H2O2 HBr, hydrogen peroxide, and HBr. What happens? They generate the free radicals like this CH3, CH dot and CH2Br. That means here break symmetrically. This Br is here and second electron is donate here. HBr break also symmetrically and they forms carbon bromine bond CH2Br, anti-Markovnikov's rule addition. They forms carbon bromine bond. This is the symmetrical breaking. They generate free radicals and such reaction is proceed through the free radical mechanism. Wherever the free homolytic fission takes place, at that time the reaction is proceed through free radical mechanism. And heterolytic bond fission takes place, the reaction is proceed through either carbocation or carbanion is the intermediate. These are the two types of fissions. लक्षात आले? heterolytic fissions and homolytic fission. What is the difference between homolytic and heterolytic fissions? दोघात काय फरक आहे? In heterolytic fissions, the bond pair electron is towards with one fragment. म्हणजे heterolytic fission मध्ये bond pair electron ह्या एकाच fragment मध्ये असतात. In homolytic fission, the bonding electron pair is symmetrically distributed and they generate the free radicals. And त्याच्यात free radical generator. It involves heterolytic fissions, involves cation or anion as the intermediates. Here free radical is the intermediates. This is about the homolytic and heterolytic fissions. Next type is pericyclic reaction. Next type मध्ये काय? Pericyclic reaction. Third, this is second type, homolytic bond cleavage mechanism. If a bond breaks in such a way that each fragment gets one electron and free radical is formed, and such reactions are said to take place by homolytic or free radical mechanism. अशा reaction ला काय म्हणायचं? Free radical mechanism is involved. And heterolytic, if a bond breaks in such a way that both electrons remain with one fragment, म्हणजे दोन्ही bonding electron pair हे एकाच fragment मध्ये असतात, which have more electronegativity or stabilized by the resonance. म्हणजे ज्याची electronegativity जास्त आहे किंवा जो anion generate होणार it should stabilize by the resonance. अशा वेळेस ते bonding electron. And the mechanism is called heterolytic mechanisms, and such reactions do not necessarily involve ionic intermediates, although they often do. Now next, pericyclic reaction mechanism. Third type काय? Pericyclic reaction mechanism. In this type of reaction mechanism, the electrons move in a closed ring. Pericyclic मध्ये काय होतात? Electrons move होतात closed ring, and there are no intermediates, ions or free radicals. म्हणजे pericyclic reaction मध्ये intermediate generate होत नाही. There is no formation of anions, that is the carbocations or carbanions, anions or cations or free radicals, and it is impossible to say that whether the electrons are paired or unpaired. म्हणजे आपल्याला सांगता येणार नाही ह्याच्यात electrons काय paired म्हणजे दोन्ही असतील किंवा unpaired, one electrons. This is about the pericyclic reaction mechanism. काय pericyclic मध्ये होतं? In this type of reaction mechanism, the electrons move in closed manner and there are no intermediates or ions or free radicals, and it is impossible to say whether the electrons are paired or unpaired. For example, double bond, single and double. What is the name of this compound? What is the name of this compound? या compound चं नाव काय?
4-butadiene.
4-butadiene. नाही. नाव काय compound चं ह्या? 1, 2, 3, 4.
1,3-dibutadiene. 1,3-butadiene.
1,3-butadiene. The name of the compound is 1,3-butadiene. Butadiene. It is used in polymer to form the rubber. The tire rubber असतात त्याच्यामध्ये याचा यूज होतो. Butadiene. Now this pi electron is here shifted. हे shift दाखवले म्हणजे काय झालं? There is formation of bond between this 1 and 4 carbon atom. 1 and 4 मध्ये काय bond तयार होतो. At the same time, the pi electron present between 1 and 2. इथं काय 1 and 2 मध्ये pi electrons आहेत. If this pi electron is take in the bond formations 1,4, at the same time this carbon acquires no positive charge. Now here bond is forms, its valence is increases, that's why this pi electron is shifted here. And product is formed is काय product येईल? Product काय येईल? What is the product? This is the product. Cyclo काय? How many carbon atoms? 1, 2, 3, and 4. How many carbon atoms? 4 carbon atoms, and 4 carbon atoms have butane, but the compound is contained 1 carbon-carbon double bond, and AN is replaced by ENE, cyclobutene. The name of compound is cyclobutene. That is 1,3-butadiene via pericyclic reactions, whether it may be photochemical or thermochemical. त्याच्यामध्ये दोन आहेत मग, con-rotatory आणि dis-rotatory. तुम्हाला pericyclic reaction झाले का चॅप्टर हा? Pericyclic झाले का? And they forms the cyclobutene as intermediate, and such types of reaction does not involve any intermediates, that is ionic, cations or carbanions, free radicals, or any other intermediates. These are the simultaneously takes place like this. This pi electron is shifted 1,4 and second pi electron simultaneously shifted, and they forms the cyclobutene, and such types of reaction is called the pericyclic reaction. Pericyclic reactions. Reaction la pericyclic reactions is called. These are the 3 ways we determine the mechanism of organic reactions. आपल्याला 3 पद्धतीनं organic reactionचं mechanism determine करता येतं. Which are these 3 methods? Heterolytic bond cleavage mechanism, homolytic bond cleavage mechanism, आणि pericyclic reaction mechanism. ह्या 3 टाइप ना आपण reaction mechanism determine करू शकतो. Bond break heterolytic मध्ये काय होतं? If a bond breaks in such a way that both electron remains with one fragment, म्हणजे त्याच्याकडे एकाच fragment कडे 2 electrons, and possibility of generation of ions, cations or carbanions, and the mechanism is called heterolytic mechanism, and such reactions do not necessarily, गरज नाही की ionic intermediate generate होईल, पण generally generate होतात. Homolytic bond cleavage, if bond breaks in such a way that each fragment gets 1 electron. Homolytic मध्ये bond symmetrical break होतो आणि एक electron दोन्ही fragments वरती जातो, and free radicals are formed, and such reactions are said to take place by homolytic or free radical mechanism. And pericyclic reaction mechanism, in this type of reaction mechanism, the electrons move in closed ring, and there are no intermediates, ions or free radicals, and it is impossible to say whether electrons are paired or unpaired. म्हणजे pericyclic reaction मध्ये there is no any intermediates. Pericyclic reaction मध्ये intermediate नाही, ions generate होत नाहीत किंवा free radicals, and it is impossible whether the electrons are paired or unpaired. हे 3 गोष्टी लक्षात आल्या. ह्या 3 मध्ये काय प्रॉब्लेम्स? 3 मेथड्स आहेत, heterolytic bond cleavage, homolytic आणि pericyclic. ह्या 3 वेनी आपण reaction mechanism predict करू शकतो. Now methods of determining mechanism. Actual methods काय available आहेत? आपण कसं mechanism त्याचं determine करू शकतो? There are number of commonly used methods for determining mechanisms. त्याच्यामध्ये भरपूर methods आहेत. Isotopic labeling आहे, kinetic controls आहे. In most cases, one method is not sufficient. म्हणजे कुठे ठिकाणी एक मेथड सफिशियंट नाही, and the problem is generally approached from several directions. Hammett explained that one approach for determining mechanism is the application of broadly arranging principle, but another approach involves bit by bit development of empirical generalizations aided by theories of approximately validity. जे काही theories आहेत, म्हणजे कार्बोकॅटन जनरेट होतो, कार्बॅनियन जनरेट होतो, how the intermediate is more stable, this intermediate is less stable, intermediate trapping, then characterizations, isolations. like this, and whenever they seem either to rationalize a useful empirical conclusion or to suggest interesting line of experimental investigations किंवा आपल्याला ते experimental line suggest होईल. These are the methods for determining of mechanism. There are a number of commonly used methods for determining mechanism. In most cases, one method is not sufficient. एक method sufficient नाही. And the problem is generally approached from several directions. And Hammett explained that one approach for determining mechanism is the application of broadly ranging principles, but another approach involves bit by bit development of empirical generalization aided by theories of approximately validity, and whenever they seem either to rationalize a useful empirical conclusion or to suggest interesting lines of experimental investigations. Now, determination of the products formed. आपण अगोदरचा point, methods for determining mechanisms. Now, determination of the products formed. Reactions मध्ये किती product generate होतात and which product is the major and which product is the minor. This is the determination of the products formed. The mechanism of any reaction should tell us about all the products formed and the amount also. म्हणजे mechanism मधून काय करणार आपल्याला किती product form होतात आणि their percentage aid or actual amount is formed. त्याच्यामधून त्या प्रत्येक प्रोडक्टचे अमाउंट्स किती तयार होते 10%, 20%, 90%. Like this. Suppose we carry the reaction A plus B converted into D plus E. So percentage of D and E identified through the reaction mechanisms and other factors. If D obtained in 98%, E obtained in 2%. This is the minor product. E is the minor 2%. 98% high and D is the major product. We should be identified which is the major product by using methods of determination of product. Even it should account for the formation of any side products. Mechanism मधून आपल्याला काही side product तयार होतोय का हे सुद्धा identify होईल. Though it is formed in very small amount. जरी तो intermediate small amount मधून form होत असला तरी आपल्याला we get idea from the reaction mechanisms. The yield and purity of each products depend in part on competing reactions. Yield कशावरती depend? Yield and purity of each product depends in part on competing reactions. जी reaction just very fastly stable intermediate असेल त्यावरती त्याची yields as well as the purities depend. Of all available ones, most useful information can be obtained by study of products obtained in course of a chemical reactions. In organic reactions, more than one product can be obtained. So in order to determine the mechanism of reaction, one should know the relative amount of products formed. How much amount of product A, product B or product is formed, we should know, and this can be done by various methods available like chromatography and spectroscopy etc. And how determine the amount of product? We determine the amount by product using chromatography as well as the spectroscopic methods. Examples for this. A well-known example of the application of mechanistic understanding to help control products in alkenes react with propene, reacts with hydrogen bromide in absence of peroxide and trace of the peroxides, addition according to the Markovnikov's rule and addition according to anti-Markovnikov's rule. Control product yields is also commercial significance. Example, the addition of hydrogen bromide to alkene which may occur via cationic or radical mechanisms. Pure alkenes in absence of peroxide react to give two bromo products by Markovnikov's addition, and in presence of peroxides or other radical sources, anti-Markovnikov additions gives one bromo products. We studied this example from first year F5 BSc, even 12वी मध्ये सुद्धा हे तुम्हाला example झालं असेल. Markovnikov's addition and anti-Markovnikov's. One propene CH3 CH double bond CH2, propene. Suppose we add just HBr, hydrogen bromide, no peroxide, no any other. CH3, CH, how many products is formed? Possibility, how many products is formed?
Two.
Two products, CH3, CHBr, and CH3. Plus CH3, CH2, CH2Br. Percentage. आता याच्यातला major product and minor product. Out of two, which one is the major and which one is the minor and why? Fine. कुठला major येईल and कुठला minor येईल? कुठला येईल major, minor? कुठला येईल? 11वी पासून झाला असेल एक्झाम्पल, 11वी 12वी FY SY TY MSc फर्स्ट MSc सेकंड, दिस इज थर्ड सेमिस्टर. काही प्रोडक्ट त्याला पुढचं एक सेमिस्टर झालं की इलिजिबल व्हा तुम्ही टीचर व्हायला.
Sir, in presence of H2O2 peroxide, in presence of H2O2 peroxide,
नाही नाही काही सांगायचं नाही. मी जी रिॲक्शन लिहिलंय त्याच्यातून मेजर कुठला आहे मायनर कुठला येईल?
फर्स्ट वाला मेजर.
फर्स्ट वाला मेजर येईल, बरोबर. कारण H2O2 नाही सर त्यात.
नाही H2O2 असो नसो आपल्या त्याचा काही प्रश्न नाही. मी जी रिॲक्शन लिहिलंय विच इज मेजर अँड विच इज मायनर, तुम्हाला असे प्रश्न विचारले.
पेरॉक्साइड इफेक्ट पण म्हणतात ना.
हो, पण याचा कंडिशन्स काय? प्रोपीन, हायड्रोजन ब्रोमाइड. आपल्याला प्रोडक्ट डिटरमाइन करायचं बाय युजिंग रिॲक्शन ऑर्गॅनिक रिॲक्शन मेकॅनिझम. मेजर मायनर आणि
फर्स्ट वाल्या प्रोडक्टची जर मेकॅनिझम केली तर त्यात कार्बोकॅटायन तयार होते आणि तो सेकंडरी आहे, तो स्टेबल आहे, त्यामुळे
this is the correct answer. The reaction is proceed through more stable intermediate, generation of secondary carbocation. Secondary carbocation. आणि this product minor मध्ये काय होईल? मायनर याच्यात काय होईल?
कार्बोकॅटायनच फॉर्म होईल पण प्रायमरी होईल.
They generate primary carbocations and less stable. Primary carbocation and less stable. less stable. And secondary more stable than primary. More stable. That's why 2-bromopropane is the major product and 1-bromopropane is the minor product. If we change the reaction condition, आता आपण reaction condition change करू. ठीक आहे, ह्याला थोडं याला सिलेक्ट करावं लागेल. क्लिअर करू आणि सेकंड रिएक्शन क्लिअर ऑल ड्रॉइंग्स. HBr H2O2. HBr H2O2. Two bromopropene. Two bromobutane plus one bromobutane. Percentage yield. Percentage yield. Now identify which is major and which is minor. One butene reacts with HBr H2O2. They forms two products, two bromobutene and one bromobutene. आता कुठला मेजर येईल आणि कुठला मायनर येईल and why? काय येईल? Which is major and which is minor and why? कुठला मेजर येईल? अरे कुठला येईल लवकर? टाइम संपत आलेला आहे आपला.
Sir, second all in.
Second is the major. Why? This is the anti-Markovnikov's rule. They generate the free radicals. Mechanism is proceed through here. Free radicals. The mechanism कशाने proceed होता? Free radical mechanisms, and they generate firstly large atoms. Br break and attacks on this terminal carbon atoms. Carbon bromine bond formation takes place in first step, and they generate secondary free radical, which is more stable than primary free radicals. It is the bromine पहिल्यांदा अटॅक झाला असता तर काय झालं असतं? They generate free